Let us wait for a minute or two for others to join. Okay, so by the time ma'am joins the session, you all have completed the previous lab. Have you submitted? Lab 7, have you all finished? Yes, can you hear me? Okay. So why you have not finished, Chandresh? Okay, so you submitted today by 5:30. So today's objective is like last time. Last time you performed. What was the objective? Last time objective. Others, those who have already answered. Others participate and respond. Algamal crypto system. Yes, yes. So today's topic is elliptical curve cryptography. Okay, and I think ma'am has already covered this elliptical curve cryptography. Right. So there are four objectives in elliptical curve cryptography. One of that is point generation. So create a point. Second is key generation. Third is encryption. And fourth is decryption. Let me share you the problem objective. Okay, can you see the screen, the lab objective? Okay, so this elliptical curve crypto system is little bit different from other crypto systems. And I think ma'am has already covered whole topic in the class and discussed the theoretical concepts behind point generation, right? So till now we use the key as a number, but now we have coordinates, right? So in elliptical curve cryptography, we have algebra and geometry. Elliptical curve you have already studied in your I think 12th standard, but here the advanced concept of or application of that elliptical curve is used in the cryptography, right? So that geometrical concept is used in the cryptography, so it is naturally interesting. Another thing is that once you create a point, then you have to generate a key, and when you generate a key you have to use operator, that is multiplication operator, and multiplication operator is defined as with the help of addition operator. So you have done x plus y in normal arithmetic, right? So where x and y are values. But when you have x and y, which are points, coordinates, then we have to redefine plus operator, right? So that how the plus operation over point is carried out, I think that is also discussed. And that plus operator is like if you have studied C++ and if you have studied the concept of operator overloading, so that concept is applied over here. So here the plus operator is defined differently, right? So you have points, you have key generation. Key generation algorithm is also discussed to you in the class. And after key generation is done, then you perform encryption. Now to perform the encryption, you take M, which is a plain text, and M is represented as a coordinate. Like when you create a points on elliptical curve, it generates several points, right? And one of the point on curve you take for encryption for a plain text, and for plain text that M is coordinate, a point, and then again you apply the key. Now there this is symmetric key cryptography or key cryptography, ECC. Yeah, student, it is symmetric or asymmetric? Students?
Good morning to all. Can you hear me?
Okay, ma'am will take over now from this point. She will continue.
My voice is clear. Hello, Mrudang sir.
Yes, your voice is clear, but students, the response has not come. So I was just curious about that.
So, can you hear me properly, everyone? Okay. Okay, sir. Now all are replying. So, just let me present my screen. Let me present my screen to you all. Just wait.
Yeah, I have stopped staring. You may continue, ma'am.
Okay, okay, sir. Listen, everyone, I have uploaded all the materials. Okay, so today, first of all, I will explain you what you have to do. I'm sharing my screen, and then after we'll discuss each and everything. Okay. So my screen is visible, everyone. Now it's visible. Okay. Okay, so listen, first of all, today's aim is what you have to do in elliptic curve cryptography. First, you have to, first the point generation that you have to perform. Point generation that you have to perform. Then after the next task that is key generation, then after encryption, and then after decryption. So that is this the flow of your today's program. See, I am writing in the chat window. So first the in ECC, the point generation. See the chat window, everyone. First point generation that you have to do. Then after key generation, then encryption, and then after decryption. So this is the flow of your today's program. Okay. So now, all this concept, point generation, key generation, encryption and decryption that I have explained in your class. But see, first of all, I will explain you somewhat. Again, I will give you somewhat basic idea regarding the point generation, key generation, encryption and decryption, and then after you have to implement. Okay. So let's one by one start with that concept. Now, see, all of you know that in elliptic curve cryptography, all of you know this equation y square equals to x cube plus ax plus b. So, in your first lecture, I have explained how to do the point generation. So, I will explain you one or two from first example. I will explain you and the algorithm that you have to understand by yourself, right? So this is the curve equation that is given to you. So actually, what is the for point generation? What you have to do? So for implementation, first of all, enter this value, the value of a, b, and the prime number value. So that is entered by the user. Okay. So first of all, the user must have to enter a, b, and p value. Okay. So that is entered by the user. So that is the flow of your program. So now once user enter the a, b, and p value, okay, so let's say the value of a is 1, the value of b is 1, and the value of p, that is 30. Okay, the user enter this value. Now you have to apply this point generation algorithm. I think all of you know that. So later I will show you. So what you have to do? So this is the equation for the curve y square equals to what? This is the equation y square equals to x cube plus ax plus b. Okay. Now what you have to do? So once you enter this a, b, and p value, so now what happened? Which equation you get from this equation? Y square equals to x cube plus x plus 1 more 13. Okay. Now in point generation, what you have to do? One by one, the different value of x, you have to start from 0. X equals to 0. Up to what? Up to the less than p, you have to one by one different value of x that you have to take. So now when user take x equals to 0, so now what happened? So y square equals to, here what you get, 1 more 13. And see, so y square equals to 1 more 13, and all of you know that for 1 the square roots are what? Plus 1 and minus 1, right? And if my negative value is there, then all of you know that you have to add the prime value. So minus 1 plus 13, so you get 12. So what is the meaning of it? So when x equals to 0, so at that time the two value of y I am getting, so at 0, 1 and 0, 12. So these are the 2 points over this curve that I am getting. Right. So this thing that I have explained. So this for x equals to 0. Now next, what you have to do? You have to put x equals to 1. So now here I have explained. So when you put x equals to 1, so here you are getting 3 value. So now see, here in this case, the square root of 1 are possible. So directly you can say it is plus 1 and minus 1. But see, here what happened? If y square equals to 3, the square roots are not possible. So if the square roots are not possible, then I told you that you have to check whether the 3 is a quadratic residue or not, right? So that you have to check. Now, how to check for quadratic residue? So for that, I have explained in your lecture, that is, if you want to check whether the number is a quadratic residue or not. So for that, what you have to do? So so let's say here you consider these are a and these p. So a is a quadratic residue mod p if a raised to p minus 1 by 2 mod p, that is equals to 1. So you have to calculate that thing, that is 3 raised to 13 minus 1 by 2 mod 13, that you have to calculate. And once you get one answer, if you get one answer, so that means you can say that it's a quadratic residue. And if it's a quadratic residue, then you can say that the solution is possible, right? And another thing is that is, if you are getting minus 1, then you can say that the solution is not possible. Now again question arises, that is, if it's a quadratic residue, then how can you find the solution? So that also I have explained in your class, that is y square equals to 3 more 13, let's say. So if you want to check whether it's a quadratic residue, then what you have to calculate? A raised to p minus 1 by 2 mod p, that you have to calculate. Now here you are getting 1. So what is the meaning of it? The a equals to 3 is a quadratic residue, means the solution is possible. Now how to get the solution? So for that I have explained, that is, if it's not a perfect square, then what you have to do? Whatever the value of p is there, you have to add to it. right? The P is the add P to A, and then after you have to check the new value. Whether it's a perfect square, means the square roots are possible or not. So for that, what you have to do, I have explained y square equals to 3 more 13. So what you have to do, you have to add 13 to 3. So what I get 16. Now I have to check if the 16 is a perfect square. Yes. So that means the square roots are plus 4 and minus 4, and means minus 4, that is 9. So that means I can say that now when x equals to 1, so at that time y equals to 4 and 9, right? 1 4 and 1 9. These are the 2 points over this curve that I am getting. So listen, so the whole flow, similarly you have to check for x equals to 2. So see, here I am getting minus 1. So here what, here I am getting 11. The square roots are not possible, so again I am checking for quadratic residue, right? So this whole flow that I have explained, so means I can say that for x equals to 2, you can say that there is no solution, right? So this whole method that I have explained. So listen, in your lab session, how to perform the point generation. So see, first of all, the three things that is entered by the user, the value of A, B, and P. So the three values that is entered by the user. Once user enter this value, then you have to use this curve equation, and up to what less than P that you have to check, right? Now whatever the value that you are getting, now see, you have to check whether it's a quadratic residue or not. See here in our first case, what happened? Here it is 1. See here x equals to 1. So directly I can say that in this case, directly I can say that there are two square roots, okay, plus 1 and minus 1. But here in this scenario, what happened? First you have to check whether it's a quadratic residue or not, and if it's a quadratic residue, then solution is possible, right? So here see, now see the algorithm, everyone. So this algorithm that you have to follow. So first of all, calculate it and then check whether it's a quadratic. If it is equals to 1, means it's a quadratic residue, and if it's a quadratic residue, then the solution is possible, and all of you know how to find the solution, right? See, suppose let's say also one point that you have to remember, everyone. See here. In this scenario, the 3 is not a perfect square. So what I am doing, the 13 is added. So here I am getting 16. Here I am getting, here I am getting 16. So now I can say that 16 is a perfect square. But it may be possible that it's this one is not a perfect square. Then what you have to do? Again, you have to add 13 to 16. You have to repeat this cycle until it is less than equals to P square, right? So up till now, you have to check that thing. So is it clear to you all how to do the point generation? Please reply everyone so I can understand. Is it clear to you all how to do implement the point generation? Right? So you have to apply this algorithm, and based on that you have to generate the point. Okay, so this is the first step that you have to implement. Ask the user to enter the value of A, B, and P, and then apply this algorithm. And based on that, you have to generate all the points over this curve. So this is your first task in your lab session. Okay. Now, once it is done, now then after what you have to do? The next task, that is key generation. Okay. So now that part I will show you. So now, in key generation, what you have to do? See, this step that already that you have done, everyone. So now see, here in the same scenario in public key crypto system, the same scenario you have to assume, everyone. Alice and Bob, there are the two party. Now, Alice want to send the message to a Bob. So all of you know that who performed the key generation? Bob performed the key generation. If Alice want to send a message to a Bob. So assume right now Bob is performing the key generation, right? So now this A and B, that is value that is already entered by the user, right? Now here the second point of key generation, that is select E1 that is equals to X1 Y1. So now see, earlier in a point generation, over the curve, all the point you have generated, right? Now from all that point, any one of the point that you have to take as a E1. Okay, or you can do in that way. You can store that point in some array, or from that you can randomly choose anyone, right? Or another way you can do that is, see, earlier you have generated all the points over curve, right? Now from that point, any of the point that you have to choose as a even. Got it, everyone? So any one of the point that you have to choose as a even. Now select D, some integer value that you have to take, everyone. Now what is the fourth step of key generation? That is E2, that is equals to D means some integer value, multiply with even means point, right? So finally what you are getting, so you are getting some another point. You are getting the another point on a curve. So let's say, see, assume this some point, and let's say the value of D, that is, let's say I am taking 2. So what I am getting, 2 multiply with some point, 2 multiply with some point, right? So now this operation that I have explained in your class, right? These are which type of, let's say this is a P point, okay? P is some P point, so 2P. So all of you know that how to calculate the 2P, so that I have already covered in your class. So just repeat that thing so you can understand. So so basically, see here, I'm writing in a chat window, everyone. So if you want to, let's say the value of D is 2. See, if I want to calculate 2P, then all of you know that what is 2P, how to calculate 2P. Please write down in a chat window, everyone. How to calculate 2P. See, please communicate with me so I can understand everyone. How to calculate 2P. I want answer from everyone. Can you hear me, everyone? If I want to calculate 2P, how can I calculate? My voice is clear to you all? Hello? Can you hear me? Yes. Yes, Deep Janil? Yes, you are correct. So 2P means P plus P you have to calculate, right? So now again, see, if you remember that, if any, these are P plus P means these are one point and these are another point. In between, if I want to perform the some operations, right? So the 3 cases that I have discussed. So can anyone remember that thing? Which are the 3 cases? How many cases are there? 3 cases, right? So can you remember that thing? Yes, Janil, you are correct. The P plus P means case number 2 that I have to use. Okay, no problem. Okay, let me show you. So 2P, that is P plus P. So now see here. So that means any point is given to me, right? Any 2 point is given to me. And if I want to perform the addition operation, then all of you know that. So after performing the addition, I am getting the another point, right? R equals to, let's say, P is some point. That is a Q is another point. If I am performing the addition operation, then I am getting the on a point that is x3 y3, right? So now see, again, I will not repeat that theory part, but see, I told you that the 3 scenarios are there. The P is not equals to Q. That means see, the 2 points are different, right? So in that scenario, I told you that if you want to calculate x3 y3, means the third point you want to calculate, then this formula, if P is not equals to Q, then this formula that you have to remember, that is x3, that is equals to lambda square minus x1 minus x2 mod P, and y3, that is equals to lambda in bracket x1 minus x3 minus y1 mod P. Okay, and where lambda that is equals to what? I told you that is lambda that is equals to y2 minus y1 divided by x2 minus x1. So by using this formula, you can calculate. Now then, after the second case that I have discussed, see, second case that I have discussed, that is P equals to Q, means see, then the line will be tangent to a curve, right? So this scenario that I have discussed. So in that case, the slope of the tangent that you have to calculate, and based on that, I have discussed in your theory part how to calculate lambda. Lambda, that is 3x1 square plus a divided by 2y1. Okay, and then what is the case number 3? So the case and the x3 y3 is calculated by using the same formula, right? That already that I have discussed. So you have to refer to this manual so you can understand. And what is case number 3? that is the 2 points are additive inverse of each other, means if P is what x1 y1, the second point Q, that is what x1 minus 1, and that is, you can say that Q equals to minus P. So we will see the scenario so you can understand. So these are the three cases. So now see, first of all, what happened. So for your lab session, what you have to do, everyone? First of all, ask the user to enter the value of A, B, and P. Then after, you have to perform the point generation. Once the point generation is done, then after you have to do this key generation. But see, for this key generation, what happened, this multiplication is required. So let's say I told you that that is D is 2, so you have to calculate 2p. So for that, 2p is about basically P plus P. So that means you have to that means what you have to do, you have to create a function for this that include all these three cases. Clear, everyone? You have to create a function, right? For this addition, you have to create a function, right? Because for this multiplication, this function is required. So before for this key generation, this function is required. So individually, you have to create this function for addition, right? So in that, all three cases that you have to cover, everyone. And then after, see, now I will show you example, so it would be more clear to you, everyone. So now see, let's say these are the 2 points. Okay, now, and the prime number is given to you. If you want to perform the addition, so that case would be more clear to you. So what you have to do? So now here you can say that the P is not equals to Q. That means the case number 1 is applied. So how to calculate the lambda? Lambda, that is equals to y2 minus y1 divided by x2 minus x1. So by using this equation, you have to calculate. I will not show you how this how to calculate. I will not show you each and every operation. So finally, when I am using this formula, I am getting 5. Now how to calculate x3? X3, that is equals to lambda square minus x1 minus x2 mod prime. So by using this formula, I am getting 11. And once I get x3, so I have to put this value over in this equation, x3. So how can I calculate y3? So y3 equals to lambda in bracket x1 minus x3 minus y1 mod prime. So, and then you get 2, right? So that means here I can say that if P is 4, 2, Q is 4, 10, 6 is given, then what I get are, so that means the addition of, after performing the addition, I am getting this answer. Clear, everyone? So these my answer. Now then, after also that I told you, suppose this type of point is given to you. Now if you want to calculate 2p, so all of you know that 2p is what? P plus P. So now see here, you can say that the case number 2 is applied. All of you know that, right? There is no need to explain. So if it's case number 2 is applied, then you have to use this lambda formula, right? 3x1 square plus a divided by 2y1, and based on that you can calculate lambda, and x3 and y3 formula remains same, right? So in this way you can calculate this 2p value. So remember, everyone, so first of all, once point is generated, you can select any of the point in a key, right? Now then after, you have to, in key generation, you have to select any D. Let's say I am using D as a 2. So 2 multiplied by E1. So for that, all of you know that. So see, these are the steps that you have to follow. But see, for this key generation, first of all, you have to implement that function, right? You have to create one function that for this addition operation, right? Which cover all that 3 cases, right? So based on that, you are getting this E2 point. Okay, now once the E2 point is generated, so now you can say that on both sides the 2 keys are generated, public key and private key. So which are the public key? E1, E2 and EP, these are the public key. And what is the private key? D is the private key, right? Now up to this, clear, everyone, what I have done up to key generation? Please let me know, everyone. In implementation, what you have to do, the flow is clear up to this? It's a single value. It's not a point, Priyank. Okay. Other students, is it clear to you all up to this in key generation? See, any value you can take, Dev. Any value you can take. See, because actually, see, now for that addition operation, see the generalized function that you have to implement. So whatever the number you are taking, it's fine. It's up to you. Clear, Dev, what I'm trying to say? If you want to calculate 4p, so basically 4p means what? It's a 2p plus 2p, right? So first you have to calculate 2p, then after you have to calculate 2p plus 2p. Clear? If the value of d is 4, so basically it's a 4p. So for 4p, what first you have to calculate 2p plus 2p. Once p is given, so first you have to calculate 2p. Once you get 2p, you have to calculate 2p plus 2p. Let's say you have to calculate 3p. So for that, what you have to do? So first you have to calculate 2p, and then after you have to add p. But see, basically what you can say that the addition in between the addition operation is useful. So initially for this key generation part, first of all, you have to implement that function, addition function, right? Now see, now on Bob side, the public key and private key is generated. So now once on Bob side, public key and private key is generated. So now what the Bob will do? The Bob send this public key to a what Alice. So now what Alice will do? The Alice has some plain text. Now with the help of this public key, Alice encrypt the message. Okay. So now here the plain text M is there. So remember that here the plain text M that you have to take point. And which point you have to take? Basically, M is a point, but which point? So the point that you have already created for a curve, right? Initially for implementation, right? For the curve you have created all the points. From that point, any of the point you have to choose as a M. Clear, everyone? Not other point you can take, right? Whatever the point over curve is there, only that point you have to take for a M. Clear? M must belongs to the curve. Clear? That you have to keep in mind. So see, already first you have generated all the points. From that, any of the point you have to choose as a M. Now then after you have to randomly select any integer value that you have to select, right? So what you get here, C1 equals to, you have to remember this formula, C1 equals to R, some integer value, multiply with E1. E1 means this some point. Okay. And C2 equals to M plus R into E2. Okay. M plus R into E2. So now in this way, so here M is 1 point, R is an integer value, and E2 is another point. So again, see, when you observe that here, suppose let's say C1 equals to R, that is some integer value, multiply with E1 is a point. So again, all of you know that let's say the integer I am taking 3 and this is some point. So again, that scenario 3 multiply with point. Right? So again, that function is called, and based on that you can calculate. So generalized function for addition that you have to create, which cover all three cases. Clear, everyone? Now similarly here you can say that the M means it's a point plus 3 multiply with R multiply with point. R means any integer multiply with point. Clear? So in this way, the two in this way you can say that C1 and C2 means the two ciphertexts are created. Once a ciphertext is created, now what happened? So now this now the encrypt, whatever the encrypted message is there, now it is sent it to what? Now it is sent it to the Bob. Okay. Now all of you know that the Bob have a private key. So which private key? The Bob has which private key? D private key. So with the help of the private key, now what the Bob will do? Decrypt the message. So C1 and C2, these are the ciphertexts. So M equals to C2 minus D into C1. So the Bob uses this equation, and with the help of that, now Bob decrypt the message, right? So this is the flow of your program. In this way, you have to implement, everyone. Okay. And see, just quickly go through this example. I will not explain you how to solve it, so you can understand practically also how to do it. See, this type of example, see any A and B, let's say A and B I have taken 1, 1. Some point even that I have taken, this is a key generation part. Let's say some point I have considered, the value D, that is 4 I am taking. right? So now how to calculate the another point E2, that is 4 multiply with some point, and all of you know that how to calculate that 4p, right? That already that I have discussed, right? So from that I am getting 11 11. So now after this key generation, this two private key, and this is a E1 E2, this is a private key, and D, that is a sorry, this is a public key, and this is a private key that is generated. Now then after in encryption, any of the point that belongs to this curve that you have to take as a M. Now randomly you have to select any value. See, I will explain you because you can understand the implementation. That's why, right? Now then after how to generate the ciphertext. So C1 equals to, all of you know that there is the equation R into E1. R is the, let's say I have taken 1 into some point. So E1, that is a point. So I am C1, I am getting 1 4. And C2, that is equals to M is a point plus 1 multiply by with this point. So now what happened here, there is a point in between, addition operation is there. So again what happened now here, so the both the P and Q are different. So now I'm applying the case number 1 now. So now when I'm applying case number 1 here, first I have to calculate lambda, then after x3 and y3. So finally I am getting what, 0 1. So now for this addition operation I am getting the answer 0 1. Okay, so in this way you have to do the encryption. And what about the decryption? C2 minus D into C1. So C2 I am getting, that is 0 1 minus D, that is 4 multiply with 1 4. So again that is what, 4p, right? So again for that you have to use that function. Then see, now here see the scenario. So now here it's a 0 1. Now instead of that I am writing plus and then this sign. So all of you know this equation that I have explained. See the case number 3. That is if P equals to x1 y1 and second point Q equals to x1 minus y1, that is Q equals to minus P. If it's a minus, then this sign is changed, everyone. This here, this is application of case number 3, right? So here in this particular case, the case number 3 is used. So now instead of that, now it is changes to what, 11 minus 1. Right, again I am using the case number 1, and then I am finding the x3 y3, and finally I am getting the decrypted text. So I think the flow is clear to you, everyone. Yes or no? Please reply. So again, just quickly, I told you what you have to do. First, enter, ask the user to enter the value of A. Can you show that case 3 part sign change 1? This thing you are talking, Priyank, please unmute yourself.
Yes, ma'am.
Ha. See, it's an additive inverse. When you read the theory, you can understand, Priyank. Okay, read that theory part so you can understand. I have already explained. So again, I will not repeat that thing.
Okay, ma'am.
Okay, that case is covering that. So now just listen, everyone. What is the quickly go through it. So see, initially, first of all, see, this algorithm is given to you, right? So first of all, ask the user to enter the value of A, B, and prime value. Okay. Now then after you have to apply this algorithm. Based on that, you have to generate the point, right? Once you generate the point, everyone. So after that, you have to apply the key generation part. In key generation part, see here the multiplication is required, right? So, but for that, what happened? First of all, the one function that is that for addition, you have to create the function where all 3 cases you have to cover. So, generalized function that you have to create, because for this calculation, the addition is required, right? All of you know that. So, you have to implement that thing because in key generation, that part is required. So, individually implement that function, right? Then after calculate this thing, so you get public key and private key in a key generation, right? Because for this, so individually you have to implement that function. And once you get public key and private key, then after this encrypting part that you have to perform, and just remember that the M must be a point over curve, right? Only that point you have to consider for M. M must belongs to curve. And then after, once you get C1, C2, and then after you have to implement for decryption. So this is the flow of your today's lab. Now, is there any doubt? So if you have any doubt, then please ask me. Otherwise, implement the today's task. And all this material, all this ECC PDF that I have uploaded, so you can refer to that material. So is it clear to you all? Please reply. Okay, then start implementing, everyone. First, do the point generation. Okay. And once the point generation is done, so please write down in the chat window and please show the point generation. Okay. Now start implementing, everyone.
So once you finish point generation, inform us that you have finished so that we can have a look about it. Those who finish point generation, first inform us.
how many students have implemented point generation? Hello everyone, can you hear me? Point generation is done. How many students have finished? Okay, Chandresh, can you share your screen? I will stop presenting. Yes, Chandresh, your screen is visible, but you are not audible.
Now am I audible?
Yes, Chandresh.
Okay. So this is your algorithm which you have provided in the PDF.
Okay.
Here I am getting.
So can you little bit zoom? Yes, now it's visible.
Y is equal to x squared plus ax plus b mod p. Then I am finding power of y, means we are doing the y raised to p minus 1 by 2.
Okay.
Then checking if it is mod p by is equal to 1 or not. Then for 1 point we're finding 2 points. Then I am doing SQRT y1 and SQRT y, both things.
Okay.
And here I'm doing integer, so if it is not a perfect square, then it will not give me like this equation SQRT y into SQRT y it will not equal to y if it is not perfect square. So I'm adding p over here.
Okay.
Then minus multiplying to it for another point. Then we are doing mod to it, so I increment with p.
Okay.
Then adding that point into the curve.
Okay. Okay. So the points are generated, right?
Yes.
Okay. Now next, what you are doing, Chandresh? Key generation
Key
part?
generation. Yes,
Okay.
yes.
Fine. Good. What about other students? Can you hear me, everyone? Priyank is doing. What about other? Please reply, everyone. What are you doing, everyone? Please write down your status in a chat window so we can understand. Point generation. Okay. See, only one or two people giving me an answer. What about the other people? Please reply, everyone. Please communicate with us.
Yes, all students, how many of you have finished point generation function completed? Yes, those students who are regularly okay. So next task, so three or four students. I'm okay. Five, six. Okay, other students, please respond because we are deciding on whether we give you some extra time or not. That is why we want to know. So if majority of you have completed, then then I think you
Sir,
will.
sir, sorry to interrupt you. All the students done means whole program is done or only point generation is done?
Okay. So if point generation is done, then I think key generation requires other 2-3 hours maximum. So probably they will be able to do it, ma'am. What do you think?
And in this lab, will only cover this point generation only. Then.
Yes, others, those who are not regularly typing, if you have done some work up to point generation, then please type that you have finished. Okay, students, the lab objective for today is kept up to point generation, because we believe that I think you all need more time for key generation and encryption and decryption. So for lab 8 submission, you have to write a program properly tested for point generation only. All the points on the curve you can generate, and also you may include this non-singularity condition in the point generation, A, B, and so the formula for non-singularity, that also you may consider, because now we are keeping it to point generation only. So non-singularity condition also you should test. Okay, and the next lab will be on the key generation and encryption and decryption. Is that clear to all of you? Okay, those who have finished point generation, you may consider the remaining part, that is non-singularity, and make your program more robust. And the second part will be in the next lab, that is after your examination, second sessional examination. That is key generation and encryption and decryption. Okay, is that clear to all of you? Okay. Okay, please carry on those who have not finished. Okay, you may leave now.